and you have the dimensions on it. So I will give a countdown and lift my hand out of the way to mark when it is released, and you will be able to determine the time that it rolls off the end. So I'll give a countdown. 3, 2, 1, go. By rolling 2 or 3 objects at a time, in order to time them, you will use the YouTube video. You can pause it and advance 1 frame at a time, or go back 1 frame at a time with the period and the comma. And if you click on the, which way you click on there, Connor?
Right-click Settings, and then click on Stats for Nerds.
Right, okay, and that is, you got to click on the gear first, right?
Yeah, right-click.
Okay, so click, and when you're in YouTube, click on the gear, then right-click, then right-click and click on Settings and Stats for Nerds, and you'll be able to read the time running by in hundredths of a second. So we'll start off with the 2 steel objects that are about 5 centimeters in diameter. You have the more exact dimensions, and we will start them. I will start them on the starting line, as I said, with the contact point being right on the starting line. And so you'll want to time them so when the contact point becomes parallel with the finish line. And what you can do, you can get the time for the, well, you can simply read the times off. It's probably simpler than counting frames. So we will do the 5 centimeter steel objects, sphere and disc, and I'll give you a countdown so you'll know exactly where they were released, and I'll jerk my hand out of the way. So we will start in 3, 2, 1, go. Start when you're ready. Okay, we have the 5 centimeter steel ball and disc again. This will be trial number 2, and 3, 2, 1, go. Okay, this is again the 5 centimeter steel ball and disc. I have interchanged sides so that to take any uncertainty on that. And this is trial number 3, and 3, 2, 1, go. Five centimeter steel objects again, the sphere and the disc. Trial number 4, this 4th and final trial, in 3, 2, 1, go. Okay, the next set will be with 3 objects rolling. We have they're all 3.8 centimeters in diameter. We have the ball, the steel cylinder, which is the higher mass one, and the aluminum cylinder, which is considerably lower mass. So we'll start off with the ball on the inside, and we will start in 3, 2, 1, go. Okay, I got trial number 2 on the 3 objects of 3.8 centimeter diameter. This time we've changed the order of who has which track to try to even out any discrepancies there. We'll start in 3, 2, 1, go. Number 3, right? Okay, the 3.8 centimeter object, same as before, trial number 3. And we'll start in 3, 2, 1, go. Okay, 3.8 centimeter objects, 4th and final trial. We'll start in 3, 2, 1, go. All right, for the 3rd set of objects we'll be timing, we have 3 different cylinders. We have the 5 centimeter diameter steel cylinder, the same one we had earlier. We now have a 5 centimeter diameter aluminum cylinder along with it. And we have a smaller 2.5 centimeter diameter steel cylinder. So I will have to start these a little bit differently because I don't want the want to keep the contact edge up right on the start line. So won't be able to use my block, I'll have to use my fingers. So again, this will be trial 1 on these 3 objects. Let me line them up. In 3, 2, 1, go. Okay, 3 cylinders again, trial number 2. We'll start in 3, 2, 1, go. All right, 3 cylinders, 3rd trial in 3, 2, 1, go. Okay, 4th and final trial. This, to be sure we get a clean start, I'm going to have them all resting against the block. What that means is the small one has about a 2 centimeter head start on the others. So you can figure what 2 centimeters is. It is, well, it's 2.5 centimeters. That's about how much head start. So when it gets to right here is when you should time it for that. Cylinders in 3, 2, 1, go. Use the lab instructor wants to make of it. We have a hoop and we have a disc. These are about the same mass. They are very close to the same diameter. And we will simply have a 1 trial demo race between these 2. So we will simply block them up and start in 3, 2, 1, go. Okay. One final demo, just for demonstration. We have a 3-inch diameter, well, 7.5 centimeter steel ball bearing, and we have a hoop that is approximately the same, very close to the same diameter. The ball bearing is solid steel, so it's obviously heavier, but this is again just a demonstration. So we'll start them up. And release in 3, 2, 1,